Hi everyone, hope all are fine. I am doing the same lesson, that is metals and non-metals. So whatever we discussed in the yesterday, I'll just recap all the things. So what we did, that is metallurgy, 4 steps of metallurgy. One is crushing and grinding of ore, concentration of ore, extraction of metal from its ore, and refining of that ore to get a pure metal. So these are the 4 methods. In that we did only one, that is crushing and grinding of ore, and second we did concentration of ore. In that concentration of ore we did what? Hydraulic process, cross flotation process, magnetic separation, and today I am going to do chemical separation. So in hydraulic process, hydraulic washing we did, we will just wash that ore with water. So it is a basic process we just use for the removing impurities from that. Next we did magnetic separation. In that we use 2 rolls of magnet. If the ore is magnetic in nature, it will attract towards the magnet, and whatever the impurities are there, it will get separated out. So this is the magnetic separation. And third we used froth flotation process. In that froth flotation process, we use on flotation tank, we added powdered form of ore. Along with that we add pine oil and water, and we pass the air, compressed air, and because of that compressed air, their froth is formed, and along with that froth, that sulfide ore, which is dissolved in oil only, it is not getting dissolved with the water. So that froth we extracted from that floating tank. So this is the third method we used. Now today I am going to discuss about the chemical separation. Chemical separation. So what is the principle of this chemical separation? Difference in chemical properties of ore and gangue. Okay, so this is the basic principle of chemical separation. Now I am going to do a reaction. Along with that reaction, I will just explain this chemical separation. So we can take an example of bauxite ore. So what is the formula of bauxite? That is bauxite. It has a formula Al2O3.2H2O. So this is the formula of bauxite. This is the impure form of ore. What are the impurities are there in this? One is SiO2 and Al2O3. So these are the 2 impurities are present in this bauxite, and we are using there are 2 methods actually to remove this SiO2 as well as this aluminum oxide. If you are removing this SiO2 as a major impurity, then there is a Hall's process, and to remove this it is Fe2O3. Fe2O3, to remove this Fe2O3 as an impurity, the process is surface process, but we are removing both the impurities. For that we are using Bayer's method. So I will just explain what is this Bayer's method. Bayer's method. So before to explain this Bayer method, I want to explain about the aluminum oxide. Aluminum oxide, it is an amphoteric oxide. It means that aluminum oxide, it acts as acid as well as base. It depends upon the which compound it is reacting. So I will just write down here the compound, that is Al2O3 bauxite 2H2O. If it is reacting with the base, so if it is reacting with the base, it means now it is acting as an acid. So now it is reacting with the sodium hydroxide, and we know what are the impurities here in this bauxite: SiO2 and Fe2O3. Okay, so now if this bauxite is reacting with the sodium hydroxide, they are forming a compound AlO2. This is called sodium aluminate. Sodium aluminate plus which compound we are getting here? Water. And we know this Fe2O3 is also base. So its base is not reacting with the base. So this is also base, no? So it is not reacting with this iron oxide. So there is a no reaction in between this. No reaction. And if it is SiO2 is reacting with the sodium hydroxide, then what it forms? SiO2 is an acid. So it is reacting with the base NaOH and forming Na2SiO3. So this is also aqueous form of solution. And now this Fe2O3, it will remain in the solid form only. Fe2O3, it will be in solid form. So we can just filter out this impurity easily. So one impurity is already left, that is NiSO3. Now we are doing the next process to remove this impurity. So that is called hydrolysis. Okay. So now NaLO2, we are reacting this NaLO2 with hydrogen, and we are breaking this compound, that is only called hydrolysis process. And we are using here a seedling agent, that is AlOH thrice, seedling agent. Okay. So seedling agent means, for example, we are using a mango seed, then we will get a mango fruit, same. So like that we are getting compound here AlOH thrice. This is in the PPT form. And we are getting which compound again? NaOH. Okay, now in this Fe2O3 is already removed, now only one is left, that is Na2SiO3. So it will not react with this, it will not undergo hydrolysis process. So this it will be remain as it is. So how it will be there? In the aqueous form only, Na2SiO3. It is an aqueous form. And it is a PPT. So now we can easily separate this PPT from this aqueous solution. Now only one compound is there, that PPT we are heating it again. This is the second step, and now we are doing the third step. In third step, this AlOH thrice, we are heating it. Then we are getting which compound? Al2O3. Okay, so Al2O3 we are getting here in the aluminium oxide. We call it as aluminium oxide or aluminium oxide, or we can call it as alumina. In bauxite there was Al2O3.2H2O. It was an impure form of ore. This is a pure form of ore. Now, so in this process we got a pure form of ore, that is called aluminium oxide. So this is a Bayes method we explained in the chemical separation. So in this way we are separating the ore from its impurities. So this is about the concentration of ore. All the four methods we discussed in this. So next I am doing the extraction of metal from its ore. Thank you.